Alright, so you were asked to find, for this function, the domain algebraically, and I kind of just wanted you to do everything, x and y intercepts, yeah, just everything. It's a good review. Alright, so to find an x-intercept, you need to make what? Y equal to 0. Put your finger on the y. If you don't have one, that's your function notation. So this is really y equals square root of 5 over x minus 5. So let's make that 0. And then here I'm just trying to solve for x. I realize that I have a proportions. Proportions is just two fractions, and here I can just cross multiply. Zero times anything. 1 times radical 5. So I have 0 equals radical 5. True or false? Can 0 equal radical 5? Can 0 equal any other number? No. So this would be no solution. So you're not going to have an x-intercept. Raise your hand if you got that. Good. Let's do the y-intercept. Find the y-intercept you need to make. X equals 0. Let's do that. Square root of 5 over 0 minus 5. 0 minus 5 is negative 5. Did you notice what I did with the negative there? And if you put that into your calculator, square root of 5 divided by 5, and that's negative, so like negative 0.45. So 0, comma, negative 0.45. It's my y-intercept. Something like that. And then before we graph it, we've been learning how to find the domain algebraically. Partner A, tell partner B, how do you find the domain algebraically for this problem? Ready, set, go. I'm going to call on someone. Rovan, how do I find the domain algebraically? Riley, how did you find the domain algebraically? Rovan, how do we find the domain algebraically? So we're going to take this one, color, and set it not equal to 0. So Rovan, if you solve this, x is what? Not equal to 5. Let's graph this. For now, you guys can, let's go ahead and label the parts you have. 0, negative 4.5, or negative 5. It's my y-intercept. So I know my graph's going to go through there, right? What do you guys think this is going to be? What type of asymptote? Vertical or horizontal? Let's see, let's just guess. There's our infinite discontinuity. Put it into our calculators. Y equals square root of 5, extra set of parentheses, divided by parentheses, x minus 5. It looks like it's approaching the x-axis, but never touches that. So let's go ahead and sketch that graph. So I'm going to go through that point. And we already knew that because we didn't have any x-intercepts. Everyone say zoom out. So I remember last year's test, a common mistake was students didn't manually zoom out. They kind of just graphed this. That would be bad. You kind of need to show rational functions will have those two curved lines kind of opposite sides, so you better show that. And then you can do a couple of things, right? You can do range, right? All the values except for where y is equal to 0. And then today's lesson we're going to be talking about increasing and decreasing. Alright, so we didn't do the domain and range. Let's do that really quickly. Inequalities and integral notation. Alright, so the domain going from left to right. Let's start here. What is this class? Negative infinity. Let's do integral notation. Negative infinity to. We stop out. Look at the x values, right? Domain is x values. What number is that? That's 5. Can you include it? What symbol? Parentheses. And then I'm going to start back up because that's the left side of the graph. And then I'm here at the right side. So 5 towards arrow, positive infinity. Inequalities, we've been using set builder notation. We basically said you could pick all the x values such that what number can we not pick for the x values? Yeah, x is not equal to 5. See that? Pink. How about the range? Negative infinity to, looks like a horizontal asymptote. So at 0. So basically you can't pick 0, right? Does that make sense? Stop here, don't pick 0, keeps going at 0 on to infinity. And then we can actually use set builder notation for the range. All y values such that, what values are we not going to pick? Y cannot be equal to 0.